everyone. Welcome back to our Wednesday weekly live streams. This is Praveen. I'm from Bangalore. If you folks know me already from my previous streams. Great. So this week, we're doing building full stack apps with React and Hasura GraphQL. This is slightly special because we're doing the GraphQL January campaign. Yesterday, Adrian did the introduction to GraphQL, and we'll be doing streams over every Tuesday and Wednesday this month as a special GraphQL January hashtag on Twitter. All right, so today this will be the Learn React course for those who have already seen the Learn tutorials on Hasura. We have a bunch of Learn tutorials for different frameworks on hasura.io/learn. We have React, Vue, Next.js, and TypeScript, and so on. So today, the focus would be on React plus Apollo integration. This will be an Apollo client integration, and probably next week we'll focus on a different framework. And feel free to drop in the comments which framework you want to really look forward to. I'm thinking of Next.js personally. We could also try out Gatsby. Will be like a different integration, generating static sites out of it, but it has a good GraphQL layer, so that would be interesting. So today's app, this will be the real-time app that we have on Learn. The to-do app with all the CRUD operations, but with real-time subscriptions for an activity feed and a list of online users, right? Cool. So I have this repo with the backend setup for Hasura and the boilerplate React setup uh, for the initial UI wireframe of the code. So I'll just drop in on the comments or probably on the banner. So this is the React Learn course, and this will be the workshop URL, the Hasura/Reactathon-workshop. I've done this tutorial in the Reactathon workshop, if some of you folks might have attended them. But this time we'll go over building the entire app from the backend and also focus on the client integration with Apollo from scratch. Cool. So I have the boilerplate uh, app on my mission. So let me just show you the directory structure. The app boilerplate will obviously have the React components with a little bit of Auth integration from Auth0, and the list of React components for integrating all the CRUD operations in the app, inserting, fetching data, and a little bit of a different sort of pagination in the activity feed for loading older and newer items, and obviously the subscriptions for online users. So that's going to be an exciting part of using WebSockets, where we'll configure Apollo client with the subscription protocol and use Hasura's GraphQL endpoint, which will be on a WebSocket endpoint. And here we have the Hasura directory, the project directory with all the migration files ready. This will be the schema for the today's live app. So to begin with, I'm going to create a new project on Hasura Cloud. And let me click on new project. I'm going to say January app. And let's say US East database. Heroku is the fastest way to just have this one-click setup. I've already configured my Heroku account. If you've seen it from the previous stream. So this is the database URL from Heroku. I'll click on create project. Might take a few seconds. Yeah, Paul says that link shared on the banner cannot be clicked. I understand it. So I'll just drop off links for the Learn course first up. So this will be Learn course. And I'll also drop in the GitHub repo link. Yep. So that's there for both the Learn course and the repo link. You can clone the repo where you'll have the hosted directory and the boilerplate for the React code, which I just showed you on my terminal. And before that, you obviously need a Hasura Cloud project, for an endpoint that you can apply these migrations to. So I have this January app project created because it's GraphQL January this month, and I'm going to click on Launch Console to see if the project is ready. It's already in configured to apply the migrations. Cool. So the first step is to apply the migrations. What I'm going to do in my directory, go to Hasura. This is the project structure from the GitHub repo that I've already cloned on my machine. And we have migrations over here, which we're going to apply along with the metadata. So I'm going to do migrate apply. And what I'm going to do is I'm going to configure the endpoint over here to my app. So I'm just going to copy this over the V1 GraphQL portion. And I would just say migrate apply. It's fine, the CLI is up to date. Now this will apply these migration files to the Hasura project. We have a slight latency due to the different regions where the project is and where I am from. And it's applied, so let me actually go to the GraphQL tab, and we can see the queries coming up. And we have the tables over here. This is the typical users table, to-dos table, and the online users table. Cool. So as a first step, I'm just going to create some data. This will be, let's say, first user, the ID, just random. Use probably a user from the comments. Let's use Paul. We have the create set being a default, last seen and passwords are being null, so that's fine. We can come back to the values of them later. Cool. So I'm going to make my first GraphQL query on this schema. This would be users followed by the ID and name columns. And I've gotten the data back from the database. Cool. So we have data for users. Now let me actually try inserting a mutation, inserting some data to a mutation to the to-dos table. So we have the relationship already established through the metadata. So I'm going to go back to to-dos and show you the different relationships that are configured. So to-dos table has a mapping to the user table as a one-to-one. So each to-do will be mapped to one particular user. So we have like an object relationship, and users who will have multiple to-dos. So this will be an array relationship where you have like an array of data in a JSON structure. And you have this view called online users where we'll have a computed data coming in based on the last seen timestamp of the user. So this will, we've created a Postgres view to identify the list of online users. This is primarily just an interval to calculate who's online in the last 30 seconds. So this is like a 30-second interval that we're calculating on the fly. And this SQL query would be executed every time we make a query to this view. So that this is mostly computed data, and we have probably relationship from online users to the user table as well, because this primarily has just the ID of the user, but the other metadata about the user, like the name and email or password, whatever other columns that you might want to access, we can do it through the relationship called user. Cool. So coming back to the mutation, I've inserted a user before directly through the UI. Now I'm going to insert a to-do and then assign it to that user. We have a couple of mutation options. We have insert to-dos and we have insert to-dos one. So the second option is typically used when you have only one to be inserted. The first one, if you have like a bunch of, like an array of to-dos to be inserted in one shot in a transaction. So this one, I think insert to-dos one is going to be suffice for this use case. So in the to-dos fields, we on the left Explorer, this is the plugin from OneGraphWorks. This Explorer will give you the fields that are required to be inserted. So we have the title of the to-do. Let's say GraphQL January, and we have it's public, which let's say it is false for now. And whether the to-do is completed or not, that also I'm going to say false for now. Finally, the user ID column. So this, I'm going to assign it to, I think it was test user. Just going to reconfirm that before inserting. Then I will get back the ID of the to-do that we'll insert. We'll open data in a new tab. We have users, or the ID is the first user. So I'm gonna make use of first user. We have the to-do inserted and the response coming back as ID1. Awesome. So let's go back to to-dos table. We have the to-do inserted over here, tagged to the right user ID. And obviously this will not work if I change this to something else, maybe first one user, then this will say a foreign key constraint, because we have set up a constraint that the user ID column has to exist in the users table. So the constraint fails if you give a non-existent user ID. Right, so the permissions are also configured. We'll quickly look at that as well. So for the users table, there is a There's a permission configured for select and update operations. The user is not going to be directly inserting into their own table, primarily because the sign up or the auth flow happens externally. In this case with auth0, and then we have like a rule which executes to insert into the user table. So that's what we're going to use for the insert. So we're not going to directly allow users to perform the mutation. For select, we have the user to be able to select any row without any conditions. But the number of columns that they can select is restricted to just the ID and the name. This is because we don't want users to see their own password or the last seen column, which will be available as a derived value in the online user's view. So this makes sense. The select permission is there, and then we have the update permission. So if you look at who can update a user, it has to be an authenticated user updating their own data. In this case, we're going to make use of session variables like Hasura user ID, which will come in from the JWT token. So I'm going to say ID equals Hasura user ID. So this condition basically ensures that we have a constraint before you can actually perform an update. And the column update permissions is basically just to allow the last seen column to be updated. So the user can technically only update their last seen timestamp as soon as they come online after logging in. They'll be able to perform this update, the last seen update from the client. So that's the permissions for the users table. Going back to the to-dos table, same thing here. We have the user role, but here we'll have to configure permissions for all CRUD operations. And similarly over here, the insert permission would be configured for user ID, where the user can insert into a to-do if their user ID matches the user ID that they have sent it in as the token. So we have the custom check configured for user ID equals Hasura user ID, and obviously the permissions for columns are also restricted to allow only title and is public. User won't be able to select is completed or user ID columns. So if it's a private to-do, they won't be able to set the value themselves. So it is configured through permissions. It's restricted through permissions, in fact. So and coming back to select, select is slightly elaborate. Here we have like an OR condition, a Boolean OR condition. We're saying for a user to select a to-do, either it needs to be a public to-do or the to-do must belong to the user who's trying to access the to-do. In both the cases, the condition allows the user to select the to-do. So it has to be either the public visibility of the to-do or whether the to-do has been created by the user themselves. That's a couple of conditions in an OR expression that's been configured over here. And for access to columns, we don't have any restrictions. We have configured for all columns. Typically for selecting to-dos, once you're authenticated to select a to-do, you might need all of this information to be processed on the front end. So this even including the ID for probably your front-end client to generate some divs or LIs. So that's what it is. And for the update, we have the same permission like the insert. The user ID has to be equal to their Hasura user ID, the session variable. So this is primarily to ensure that only you are able to insert, update, and delete your own to-dos and not somebody else's to-do. So this is typically the condition that's used for restricting that kind of a use case. And the columns for this particular use case, we have a couple of columns, the title and is completed columns. The user won't be able to change the public visibility of the to-do directly. Once a to-do has been created on the private list, you cannot really like migrate away to a public list directly on the UI. So it's like just a UI constraint. So we're just not allowing the permission to do the same. Same thing on the delete, very similar to the insert. We'll have like a custom check for the user ID. If the user ID matches it, then we allow the delete to go through, else you cannot. Finally, for the view, we have just a select without any checks. Anybody can select this view as long as they are obviously logged in. So if they send in the token, they should be able to fetch this data. Right, so that's the bit about permission. And if folks have any questions, feel free to drop in the comments. Right, so the next step would be to secure the app. So I'm going to configure an admin secret. Right, so close this. Right, so I have now configured it with my admin secret. I'll probably have to refresh this, then reconfigure my console. Right, so now all my requests will go through with the admin secret header, and I can probably remove it and then show you that the schema is not available if I don't have the admin secret enabled, because I don't have any other permission configured for without this admin secret. The other way is to obviously have the role and user ID information passed along. So here I'm going to pass in the role, and then the next step would be to pass in the user ID. Here I would add in the first user value, and yeah, I'm going to close all of these and enable this. Now, if I'm going to query this would be to-dos ID followed by title. We have the to-do data coming in. Now, to test out the permission, I'm going to create another to-do. And of course, we'll need another user as well. So I'm going to create a second user. And I'm going to use Andy, who's asked the latest question on Twitch. So the question is, none of these requests are authenticated. Right now, we've not configured any form of authentication. So that's what we're going to do right now. The next step is to configure Auth0's configuration onto Hasura. And then any more requests you send without authorization header will fail. And we'll see how to overcome that with the GWT configuration. But right now, in fact, since we've configured the admin secret value, you won't be able to make a request without the secret. So the public, any user who's trying to access this endpoint, they'll need to know the secret value to be able to access the data. So it's already kind of authenticated in the sense of you're you can make admin only requests right now because it's configured with an admin secret. So the data is already like kind of secure. Right, so I have created a second user and I'm just going to quickly make a to-do, make requests indicated, completed, would it be false? Or in fact, it's true because we've just configured an admin secret. It's not a public to-do. And then we'll say second user. So we have a couple of to-dos now. I'm going to go to history and then make the query again. We can see that the second to-do that we created has not been returned in the response. This is because we are passing in the role and user ID values to match the first user. The role is obviously common. We are sending in the user role. But if you look at the user ID value, we are passing in the first user. So if I pass in the second user, I'm getting data which belongs to the second user, or the data which is authenticated to be accessed by the second user. So that's the permission system. We've tested the permission system with the admin secret configured. Now the next step is to configure it with some form of an authentication provider, like a full-blown auth provider. And to do that, we are going to make use of the JWT mode in Hasura. For this particular React app, we are going to use Auth0 for the configuration, and the login UI is powered by Auth0. In fact, I'll show you the demo of the app. I forgot the UI structure of the app. I already have an account. Just going to log in and then show you the UI. So this is the Auth0 login UI. And then this is the actual UI that we're going to build. And I'm currently being shown as online after logging in. I have a list of to-dos. There's a list of public to-dos, which you can scroll through. So this is the app that we're going to build. And we had the Auth0 authentication happening in the previous step. So that's why we're going to replicate. Cool. So coming back to the configuration. So now for the Auth0 configuration to work, we need to set up a tenant in Auth0, create an application, create an API, set up some rules, and so on. So I'm going to skip those, which I assume is part of the Hasura course that we have over here, which is covering authentication. I'm going to drop this link in the comments so that people can take a look. This will have the steps to create an application in Auth0, set up rules for setting up custom claims, and how do you connect Hasura with Auth0. In fact, this is a step that we're going to do right now in the current app. I'm skipping the Auth0 app creation and the JWT claim step because I have the GraphQL tutorials Auth0 domain ready and working. So I'm going to make use of that app. So going back to the cloud project, I'll have to create a new environment variable called Hasura GraphQL JWT secret. The value of this can come from the JWT config page. I'm going to post this on comments as well. Awesome. Cool. So now I have the provider Auth0. I'm going to click on GraphQL tutorials.auth0.com. This is an Auth0 application that we've created for the Learn courses. So this comes with all the callback URLs configured so that localhost 3000 on your React app works. And it is also configured with the custom claims of Hasura with the role user and the proper user ID values being templated. So this generates the key. I'm going to make use of this key in my cloud project, and I'm going to paste it here. This is the GraphQL JWT secret. I'm going to click on add. Now, once this is added, you won't be able to make any unauthenticated requests apart from the admin secret as well. So you won't be able to make requests like sending in access to a role manually over here in your request without the admin secret. And you will obviously need to send in the authorization header. So the way it looks is you need to send in authorization followed by the bearer token. Here you will have some token value coming in from the authentication provider. That would be Auth0, I suppose. In this case, this is definitely Auth0. So now that this is configured, we need to now go to the generation of the token business. Since this is a pre-configured Auth0 application, I'm going to make use of the GraphQL interface to generate the token. Generate a token. I'm going to post this link on chat. I'm going to click on login, and this will prompt me for the Auth0 login. Since I already have an account, I'm just going to probably I might sign up for a new account for the campaign. Let's say GraphQL Jan at Hasura.io. Cool. Close this. Now, this is a slightly custom interface that we've built. This is similar to what you see on the Hasura console over here, but it is just integrated with the Auth0 login interface, and it will template you the authorization header coming in from the Auth0 token. So this bearer token is what we are concerned about. I'm going to do is I'm going to add this token over here. Now we should ideally be able to start querying. Obviously, the data is empty because the token has a user which doesn't exist in our data users table. So let's look at what the contents of the token looks like in jwt.io. We have this debugger interface. I'm going to paste this token. I think we begin. Yeah, I've removed the bearer portion. Now, if you look at the decoded payload, you can see that there is the JWT claims object having information about the role and allowed roles and user ID, and coming in from my email address for some other metadata, which is auto completing these values. But the primary focus should be around these three values. These are generated on the fly for every login. We are assigning a default role called user and a list of allowed roles, in this case, just user. And user ID is coming in from Auth0's user ID value. This is the user ID that we are concerned about, and we're going to add it to the data tab. So I'm going to go to data and create a new user, in fact, with this ID and tag it to my name. and I'm going to leave the others default values. And obviously I need to also create a to-do. So created a to-do. Completed is false. Let's say Boolean is false. And the Auth0 ID, I'm going to paste it for the user ID. Awesome. So go to API Explorer. Now we can see that with the authorization bearer token configured without the admin secret, I have actually unchecked the admin secret. So we're not sending in the secret anymore. And I'm sending in the authorization bearer token, which was created for my particular email address. And this is giving me the data that I have created for my user ID. And the permission system is working. So we have configured Auth0 JWT secret, which is just the public key value coming in from a pre-configured Auth0 app. And once this is configured, we've made a request to the learn GraphQL / GraphIQL URL, which triggered an Auth0 login and gave us this token. We have used this token to now start making authenticated requests as the user. Now, in fact, if I enable the admin secret and make the request, you can see that all the three to-dos in the database come in the response. This is because the admin secret has the power to fetch everything. There is no restriction for the role admin, and the admin secret, if passed in as in the header, will be able to just perform any action. And typically, this is something that you will never do from the client. An admin secret will never be passed as a header from your front-end client. Your React app will never send this. This is just more for an experimentation on the Hasura console to just do some data fetching as an admin. Even if you're building an admin dashboard in React, uh, you are requested to create more granular roles and then configure permissions accordingly before using it on your front end. And because if anybody else has access to your admin secret, then you are basically like losing access to your project. Anybody can manipulate your data, fetch data. So this should never be used on the client. But the authorization header, on the other hand, once you've configured your authentication provider, this is something that you will be sending in from your front end. So once the Auth0 login takes place, you have this information in your state in some form, and then in your GraphQL client, you will be able to pass this as a header. We'll see that in a while on how to configure a Apollo client in the React app, and then we'll see how to pass in the headers that we just saw now. Cool. So the JWT secret is configured. Permissions have been tested out. Now the next step is to go to our React app to start the front-end integration. Unless there are any more questions on the chat. Cool. I think there are no more questions right now. We can move on to the React boilerplate setup. So this is the course URL as I mentioned before. We are going to begin with the client setup with Apollo to start. The boilerplate app UI is already ready. So what I'm going to do is head to the app boilerplate setup. Hope the code is visible on the terminal. If I want to zoom in more further, do let me know. I'll do npm CI. Awesome. And meanwhile, we look at the project directory structure once more on the React side. We have the Auth0 configuration over here. We have the Auth0 variables. We have the login setup, which is just like a front-end UI for uh, triggering an Auth0 login, which takes you to the redirected URL. And we have a callback URL, which is just an intermediary URL that Auth0 sends you to. This is the React Auth0 spa.js, where the logic of the authentication takes place. There are a couple of functions that are being called, and if there is an authenticated user, then the Auth0 context is being passed to the component, to the login component. And we have the to-do component where we have the private list, private wrapper, the public list, and the input component. We'll actually open the app and then we'll have a better idea. Yeah, the modules are being still installed. I keep having different versions of Node.js and the binaries, especially for Node SAS, keeps changing, and because of my change in versions, they always end up in some sort of an error. So I'm going to do npm start on this. I'm running on Node 12. I think that should still work. Typically, we have, yeah, Node 10 is more stable. 12 should also be working without any issues, ideally. Yeah, so the app is running on localhost 3000. I'm going to open this. In the same login setup. This will work now because the Auth0 session is already created. This is the UI that we're going to integrate with Apollo client and the Hasura GraphQL endpoint. We are going to show a list of personal to-dos, which is just the private to-dos on the table. So the Boolean flag is what we have to concentrate on here. And we have the public feed, the real-time feed, which will be like an activity feed, like a Twitter style activity feed. Once you have new tasks coming in, you will have like a notification at the top, and then you will show in the older to-dos at the bottom. So they keep stacking up. And the last bit is the online users, which is what I'm most excited about in demoing the GraphQL subscriptions portion. And obviously, the two to-do components will have an input component to create a new to-do. The twist over here would be for the private to-do. I think we have optimistic mutation. So before the mutation is successful, the UI will assume that the mutation was successful and then update data on the front. And once the response comes back from the server, everything is normal. But if there is an error, then you revert back with an error message saying that this failed. So that's another subtle feature that we see for the mutation. But apart from that, we have subscriptions over here. We have queries on the left, and this will again have like a mix of queries and subscriptions. We have to listen to a subscription to see if new to-dos have been created on the public feed. And if so, if I click on this, then it should make a fetch call at that particular time and then populate the public feed. And the load older task would be to just make a simple fetch, like a query, like a GraphQL query, and template the data over here. These filters are client side as of now, but you can see that this could be like a GraphQL query as well. Right. So I'm going to uh, install Apollo client. So going back to Apollo docs, the first step is to do the npm install for these two modules, the Apollo client and GraphQL. So I'll do this. Just trying to ensure that this is entered. Yeah. So this is one package which contains all the necessary libraries that are required. This is from Apollo Client 3, version 3. Before version 3, I think in V2, Apollo Client had multiple modules that you install separately and then import them. Now they've bundled it into one particular client, one particular package. The GraphQL package obviously is required for parsing the GraphQL queries. We'll see how this fancy GraphQL syntax can be used in a React app. That is where the GraphQL package comes into the picture. Right, npm install always takes a lot of time. Awesome. So now we have Flow client and GraphQL package set up. This will open up the same app, so you don't need to worry about this. Right, so coming back to the component structure that we were looking at on the front end, we have the private list. This is what we saw on the left most of the app. We have the to-do item, which is the list of to-dos. We have the to-do input, which is the input component for creating a new to-do. This is shared across both private to-dos and the activity feed. Filters, this is client-side filtering, so we might have some conditional checks to filter out the to-dos. This is fine. The to-do public list is the activity feed that we saw in the middle, which will have some older to-dos and newer to-dos. And finally, online users, we have the list of users coming in from the Postgres view. If you remember, we had an online underscore users Postgres view, which computes the list of online users based on the last seen timestamp. This is where that template will happen. And there's like a wrapper over that. Right, so we'll start off with the this closing off all tabs. We'll start off with the to-do private list. Closing off callback. Login, we're not going to look at that. This is constant, so this is fine. Index. So yeah, so we have the routing setup. Obviously for slash, we have the Auth0 provider, which will render the other components. The app.js will be called in if the login is successful. So this is where the initial loading will happen after the login is succeeded. So I'm going to import Apollo client and see what we can do with that module. So we have a bunch of uh, things to import. We have Apollo client, we have provider, and we have in-memory cache, and finally HTTP link. We'll see why these modules are required. This is from at Apollo slash client, the module that we install now, which is all of these bundled together. So previously with V2, this had to be separate modules. I think some of them were in separate modules. Right, so this is the first step where you import all the Apollo related dependencies. in the first app. And then we'll need a way to create an Apollo client. So what I'm going to do is I'm going to create a function to create an Apollo client, the function will accept like a token that will be sent, and the function will return back a new instance of Apollo client with all the URL and the headers being configured. And ideally, I would like to call that function from inside of my app component. So it would be something like this. I would want to do const client, and I would want to call a create Apollo client. I'll pass in the token. That's what ideally I would want to do. And the reason being that I would want to wrap this entire component, the entire div, with the Apollo provider passing in a client. So Apollo provider client is equal to clients. Just gonna paste this at the bottom. Right. So this is obviously the private wrapper, the public wrapper, and the users wrapper, the three components that you saw on the UI. They're split out into different column D. This is Bootstrap. Right. So we have Apollo provider, and we'll need the client to be passed in. So this will be the context for all of the components. The child components will have access to the client. Right. So for the client to be created, we'll need to create create Apollo client function for this app, return, and the create Apollo client accepts a token as a argument, because I'm going to pass this ID token that comes in from Auth0 to the Apollo client creation function. This needs to return something. This needs to return a new instance of Apollo client, and it needs to have the configuration for Apollo client. So I'm going to say create, return a new instance of Apollo client, which will have a bunch of configuration. Which will have at the top level, it will have like a link that needs to be configured, and cache that needs to be configured. The link properties um, for indicating whether this is like a HTTP link, or is it like a WebSocket link, or if it's like a combination of HTTP and WebSockets being split depending on the kind of request. So that's when this link would be useful. Typically, you could also just do URI and then pass in the GraphQL endpoint. But in this case, since we have both GraphQL subscriptions to be written and the normal queries to be written, we start off with the link, and we also have the cache. And for link, we need to return a new instance of HTTP link, and that's why we've imported HTTP link. The Apollo provider was used in the components return, passing in the client value. In-memory cache is something that we'll use over here. So let's say new instance of in-memory cache. And I'm just going to do a comma separator. Okay, so HTTP link has been created. We need to pass in the URI value, and the URI will be available in my console. This is the endpoint that I need to configure. And I need to send in headers so that the requests are authorized. And this would be the bearer token that comes in. I am just going to send one header. I think content type application JSON is fine. We can skip that. This is the configuration, I guess. We are returning a new Apollo client instance with the configuration for link, a HTTP link, and a cache. Right. So now that this has been created, let's look at if the app is loading as expected. Yeah, I'm guessing there are no errors. So we have this configured. Obviously, we're not making any requests, so nothing can be tested right now. We have the instance of Apollo client configured and then sent to all of the child components as well that can be used. So the next step is to integrate the private to-dos, fetching of private to-dos. We'll have that coming in from here. So we'll have the query first. I'm going to say get or maybe fetch private to-dos. And this would be to-dos followed by all the columns that we require. So click on these columns. I probably don't need the other columns. Right. So this is the data set that we were looking for. And I'm going to import this query over here. So to do that, I'll have to import the GQL module from Apollo client. And I'm going to declare a variable for the query, to do query. Say fetch to do's. And I'm just pasting the GraphQL query that we copied from the previous console. Right, so it's just doing a little bit of indentation. Awesome. So we've written this query. We've not mentioned whether this will be filtered based on the user ID. If you look at the response over here, this is giving us data only for the ID 4, which I assume is from the user Praveen, which was created, ID and name. Yeah, so this is filtered already. The permission is already configured. So we don't need to specifically say like a var clause, fetch only the user ID, Praveen, and so on. So all of this is configured already through permission system, the role-based permission system that we saw earlier. And the query that you make is authenticated through Auth0 and authorized with the permission system of Hasura. So you can be assured that the values returned for this is respecting the permission that you've configured. So this is the GraphQL query we've configured. This is fine. The next step would be to make a request to call this. Apollo client has this, I think, this hook called use query. Here you can just import use query from Apollo client, and then they have this loading error data that you can call it. So we're going to make use of this. Let's say use query from Apollo client. So we are importing this from that, and this is the component which returns the dummy list of to-dos right now. This is the to-dos that you see on the left. And instead of returning this component, we're going to create a new component to private list. Let's call this, and it's going to return the React component for the use query. So before returning some data, in fact, we can return the to-do private list. We look at the data, the props to be sent later. We have, if we look at this, we have loading error data. So these are three properties that are returned by the use query hook. And for the query, we've declared fetch private to-dos. That's what we're going to use over here. Okay. Now, once this use query hook is executed, once this data comes back, the loading error and data comes back, we have processed that on the front end. So there's a loading state. So there's a temporary loading state before you get the final data from the server. So to handle this, you need to return like a maybe for now. Typically, this is the loading spinner that you return over here. If it's loading, return loading, and if it's error, show a nice error message. It's an error. And finally, if data is there, we'll have to send that to the to-do private list. What I'm going to do is say maybe to-dos. This will be data or to-dos. So data would be of this format. So we have data, and inside data, we have to-dos object with the list of to-dos. So I'm making use of to-dos data.todos for the props. And we've configured loading state to be handled, the error state to be handled, and the to-do private list. If both of these states are not there, then we assume that data is available. So this is the boilerplate that you require for executing a query on a GraphQL client with Apollo. The good thing is that the loading state is handled for you automatically. So you don't need to wait for your request to complete. You can rely on this loading state in the temporary state where the data has not been returned from the server yet. And of course, the error also. If there is an error in the GraphQL response, then Apollo will send back this error. And if not, then obviously you can assume that there is data coming in from the server. So then you can assume to start accessing data in the data response. So this is the good piece of boilerplate code that you can write for any query, any GraphQL query integration. Right, so now what I'm going to do is, instead of exporting this to private list, I'm going to export to do private list query, because this is the component that we want to initially render with the use query being triggered and the data being fetched and the to-do private list being called thereafter with the props for to-dos. Awesome. So now we have to remove some dummy data that we have created. We'll remove this empty list of to-dos, and we have to change the way the to-dos being accessed. So I'm going to create, we are passing in the props called to-dos, so we can pass that over here on the props. If you look at this to private list, it accepts a props argument. So we are just accessing the to-dos from the props. And instead of state.todos, I'm just going to say to-dos because we have the value directly on the to-dos constant. Everything else remains the same. State.filter, clear in progress. Yeah. Filters are client side. We're just calling this component, so everything is fine. Filtered to-dos, that functionality happens over here. Cool, no errors. Coming back to the app, I like refreshing the app to show the network call being made. So go to the XHR field. We can see that there is a post request going in for the GraphQL endpoint. And we have like an authorization barrier token being sent. I don't know if it's visible, I guess. And maybe I'll zoom in one more. Yeah. And we have the request payload, which is sent to fetch the private to-dos. There are no variables, and there is this query for fetching private to-dos, which fetches the to-dos table with the following columns. So we've effectively done integration for GraphQL query with Apollo client by making use of use query hook, and it has given us the response in the JSON format from the database, and we have the state value being populated over here. So this is already working. This is the to-do that is appearing on the database. We've now configured it on the client. Right. So the next step would be to integrate a mutation. So going back to the learn course, we have done the queries with fetch to-dos query, the use query hook. This is all done. The private list component is done. And I've imported use query and the private list query. So all of this functionality is done in this tutorial. The next step is to create a mutation. I'm just going to copy this mutation so that I can try it out on the console. This is very similar to what we tried out earlier to insert a mutation. This is the insert to-dos one. This was specifically for inserting one to-do at a time without any variables. We've just given the values directly over here. But this particular mutation has variables for the title of the to-do and the public visibility of the to-do. It also returns back a lot of data. It returns all the ID, title, created at timestamp, and the Boolean values for is completed, along with the affected rows to just say how many rows were affected in this request. This is the mutation that we're going to use, and we'll have to pass in a couple of variables, which is the to-do. Let's say test to do from console and public being true, or maybe we'll come back to the true later. I'm going to create this. So I've created a new to do with my own authorization data token. So this is going to be assigned to my user ID. We can verify this by going to data, the users tab. It's a third user, and we have test to do from console, and the user ID is mapped to the Auth0 user ID. Awesome. So this is great. We have the mutation working. Now the next step is to integrate it on the front end. Our current app has the query working. We've seen the GraphQL endpoint and we've seen the queries being made. Cool. I'm going to head to do input for the mutation integration. Step would again involve importing AQL from follow clients. The variables would be insert to do mutation. This would be the mutation that we copied from the console. Now, we have a couple of variables, so that's what we're using here. And to make use of this mutation, we'll have to create a hook, and we are importing use mutation hook, similar to what we did over here for use query. We're doing it for use mutation. And before that, we have a little bit of UI boilerplate to be taken care of. We have this input box, which doesn't have any state attached to it. We'll have to have some value and some on-change handler, which will take care of updating the state of the input box. We'll come back to those two later. We'll declare a state. I'm going to say to do input and set to do input. To state empty value. I'll also have to import use state from React. Right, so this would be to do input, and for the on-change handler, we have set to do input of e.target.value. Right, so once this is done, we have the state of input configured, and then we can use this value somewhere else, depending on where the mutation is going to be called. Yeah, these two are not being used yet. The mutation that we've declared, that's fine. All right, so the state is working fine. The next step would be to call the mutation. This would be add mutation, or in fact, let's see, add to do use mutation, which will have the insert to do mutation. And for this, we'll need to send in some variables as well. So if you look at the query variables section. So this is the add to do. This is fine. Here, if you look at the add to do integration, we have the use mutation being called, and the use mutation will have an additional value to be passed, which is the variables. So this is called in on the form submit. This add to do mutation will be called on the form submit. So this on submit function is being used over here, which is currently empty, just like a prevent default function being called. This is what we are going to call now, the add to do inside form submit. And this would be add to do. We have a couple of things to template title, which would be to do input, followed by this public value. So we need to wrap it under the variables. Keep forgetting this syntax. Right. I've now passed in variables, which will have the title and is public. This is just a shorthand notation. Ideally, this can also be written like this. Yeah. Cool. So we have title and is public. The is public values by default is false. If somebody else is sending in as true, which will be applicable in the activity feed, the middle UI that we see over here. This is where the is public value will be true. So if that is being explicitly passed as true, that will be reflected over here in the variable. But otherwise, we have this by default as false, and the to-do input coming in from the input box value, which is templated, and the state being managed over here. So this is add to-do. Let's test this out by creating new to-do from React app. And we're expecting a non-null variable to of type string. So we're probably sending in some null values. We have a mutation variables. So for to-do input, we are sending in an empty value, I guess. So going back to the variables, we have $to-do instead of title. And I think that's the error. Let's verify that. This time there aren't any errors. And if you look at the response, we've gotten back the affected rows followed by the returning of this new to do. So this query works with affected rows 1, and the data has been returned back from the server. Now the next step is to, obviously, once the response is successful, we'll need to handle it on the UI and then add it to the list of to-dos that are already there. We have the two to-dos over here right now. We need to add the newly added to-do over here. If I actually refresh this page, this will come up on the list. But we need to happen. We need this to happen on the client in a state update. So for that, we'll need to update the Apollo cache. So if you remember the first step, we had configured our app.js with a new in-memory cache, which is being maintained by Apollo. That in-memory cache will have a couple of functions to read and write to that. We're going to make use of the read query and write query functions. to perform some updates. And if you look at this, the use mutation hook has another argument that you can pass in to say which function to call for the update. So once a mutation is successful, what function do you want the Apollo client to call? So we can configure that. And this is the update cache function that we've configured over here to be called for update. And inside update cache, we have the cache and the data prop. And obviously, this is some boilerplate code for public access. This is the important piece. If you have a list of existing to-dos, you need to first read them from the cache, which will involve using the get my to-dos query that we initially used in the previous example, which is to fetch the list of to-dos. And once you fetch the list of existing to-dos, we are going to add a new to-do, which is the newly added to-do that came in the response, which will be part of this. So this is the response that we saw. We will be parsing this response and then adding it to the existing list of to-dos. So we've got the existing to-dos from the cache. We've got the new to-do from the newly inserted data response that came in from here. And finally, the newly added to-do has to be inserted into the cache using the write query. So we're making use of two properties, the read query and write query. And we have the data to be passed, which will be like a concatenation of the new to-do and the existing to-dos data as well. So that's the code over here. Let's try this out on the input. We have the use mutation. So for update, we can call an update cache function. We'll have to declare this above. Set cache. This one accepts cache and the data. And here we need to process the reading of to-dos. So we have three steps. We have read data from cache, read the newly inserted to-do, and then finally combine the new to-do with the existing to-dos and write into the cache. So this is finally write into cache. These two are kind of the same step in code snippet. So we have existing to-dos. Okay, let's do camel casing, which will use cache dot read query method. Query, I think we'll need to pass in the private list query, the fetch private to-dos. So we have to export this over here. Fetch private to-dos. And we have to import it over here. We have fetch private to-dos from same folder structure. So we'll have to do private lists. Like imported the query now. We've imported the mutation now. And the usage of that would be over here. So it would be fetch private to-dos. So the first step of reading data from the cache, this is done. Just going to recheck that. This boilerplate check for public is fine. Read query, and we're passing in the query. We have to add the new data to the cache. So before that, read the newly inserted data. New to do. Data is coming in from the response. So we'll look at the response structure once again. We have data, then we have to-dos, and we have the zero to get the latest one. So we'll have, okay, this is, I think, a read. We'll have to make another to-do to see the insert response. We have data dot insert underscore to-dos followed by the returning values. This will be insert underscore to-dos returning of 0.id, or in fact just to-do. Right. This is the same, insert underscore to-dos returning of 0. Then finally we have to do a write query, which will again use the same query for fetching the data, followed by the data itself, which will have the to-dos, having the new to-do at the beginning and spreading out the old existing to-dos. So this is the final step. And this cache.write query. So that's what we want to do here. We'll directly do cache.write query to directly write into the cache, which will update the state. And cache.write query, we have the query that needs to be passed, which would be fetch private to-dos. And the data. So for the data, we'll have to pass in to-dos, which will have the combination of the newly created to-do and the existing to-dos. So the new to-do that we've just read in the previous step, and we'll spread data from the existing to-dos. The existing to-dos will have the object called to-dos, which will have the list of to-dos. So that's what we're trying to concatenate into. So this new to-do is an object of to-do, and we're spreading out all the objects of to-dos in the existing list. And finally, we're wrapping it into an array. So we have like a list of to-dos being concatenated. So the write into cache step is this. Both these are combined to one. Now we'll try doing a mutation. Final mutation, hopefully. Final to-do created from React app. And we have this to-do being added at the end. So things are working. What we can probably also do is we can add it at the beginning so that it comes at the top. We'll have new to-do over here. We usually want the items to appear on the top, so that will be nice. Appear at the top. All right, I think This is again going at the bottom for some reason. Did I save this? Maybe the cache is acting weird. Just want to refresh this. That's true. We have this again appearing at the end. All right, so that's fine. We have the mutation working, which is what we wanted to establish over here with the list of to-dos. And the next step is to clear out the values on the input box if something changes. So we can do, so once the form submit happens and the to-do is completed, which is over here, what we can do is we can also set the to-do input to empty, so that will clear out the input box, right? Clear this to-do after creation. Now we've cleared that, and then the placeholder text appears, so that's fine. Great, so we have created the mutation as well. This step is done. We've made use of cache dot read query and write query. Read query to read it from the cache, and write query to write back into the cache, which will update the state being used. So the interesting bit is that if we are using this query somewhere else in the same UI in a different component, and if you're doing a write query on the cache, it will propagate that update to all the components which are using this query. So let's say, for example, this list of to-dos is actually also the same query, which is on the left. Then if you're doing cache.write query and then updating some state, all the components which are listening to that query, if there are any changes, it will be updated in one shot across the UI, which is nice. So you don't need to handle state changes in multiple places. You are basically reading the whole Apollo cache and writing back to the cache, and Apollo takes care of updating data across different components because the data is being shared across in the cache. That's the powerful uh, feature of using an in-memory cache or some form of cache on the client with Apollo. And this is all possible because of the type system that GraphQL has. Without knowing the type of the fields that are used, it will be impossible to trust the response that the server gives and then add it to the cache. So whatever we're doing here, this is all uh, primarily because of the schema and the types, which are allowing us to just append data and then trust that the cache will take care of the rest, the appending of data in the cache. So we are almost running out of time for today's stream. We have covered queries and mutations today, the beginning portions of it. I wanted to showcase subscriptions today, but I think I'll leave that for the next stream. We have a couple of things pending. We have optimistic UI updates pending, and we have the GraphQL subscriptions as well to be showcased. And once we have these two in the next stream, we'll also look at how the notification banner can be done on the activity feed, like a Twitter style activity feed. where you have new to-dos being created on the public feed by different people. And instead of showing it in one shot, we have like a notification banner coming up, which people click on, and then you have the to-dos popping up after that. This pattern of fetching and refetching queries based on user interactions, we look at it as part of the implementation for this component, and that will happen next Wednesday as part of this continuation of the stream. As part two, we look at implementing the rest of the app, the subscriptions especially. So we'll begin with subscriptions next week, and we'll move over to optimistic UI updates on the front end. And finally, to wrap it up on the public feed, which will have a combination of client-side subscriptions and data fetching using GraphQL queries based on user interactions. So this will be like a fun activity feed to implement next week. And I think if you have any questions, happy to answer on chat. But otherwise, I think we are done for today's stream. I'll catch up with you folks next week in continuing this app. I think so far this has come out really well. This tutorial is supposed to be wrapped up in a couple of hours, but since we are doing like a full stack setup, we spent the initial half an hour to 45 minutes setting up the backend and showcasing different queries and mutations that can be performed, and also went over the Hasura CLI migrations and metadata workflow. So I think for the next, so I think the initial 45 minutes we spent in the backend, and the 45 minutes after that, we've done the Apollo client setup with queries and mutations configured with cache updates. So it's a pretty good progress on this front. And I think we can continue this on the next stream on next Wednesday. Meanwhile, I'll post on some links. We have this GraphQL page, which you folks can check out. This is like a guide for GraphQL. If you are new to GraphQL, or if you are looking to learn about GraphQL, this is like the go-to guide. You have like the breakdown of GraphQL servers, clients, the spec, what are the different GraphQL queries, mutations, examples of them, what is the difference between GraphQL and REST APIs, and different architectures you can build with GraphQL. So this is like a good resource for you to come back and refer to. And as part of the campaign, we have this GraphQL January page, which will have the schedule listed out. We'll have a more detailed live stream schedule probably sometime tomorrow. We do the streams on both Twitch and YouTube, so do join us over there on the streams. Adrian does the streams on Tuesdays, and I do the streams on Wednesdays. So catch up with us on respective days. Yesterday, Adrian did the intro to GraphQL stream to start off with this campaign. We have live Q&A. We had one today, like I think 3-4 hours back on Discord, where our engineers will be available for your queries to answer. And we do this on a weekly basis. So next Wednesday, do join us on these times. And we have office hours every Thursday. So tomorrow, please do join in and post your questions about Hasura. And it's more like an informal, casual chat with the engineers on the team. So feel free to drop in some questions if you have any. And if you have any questions about the stream or any of the upcoming streams, do drop in a message on Discord. You can also follow me on Twitter twitter.com/PraveenWeb, and do feel free to talk about this GraphQL January theme. We have a lot of exciting content, blog posts on a daily basis that our community team is coming up with to learn GraphQL. So feel free to check out our blog as well on a daily basis. We have some new content coming up, uh, and I am excited to do the stream next week. And this month, I am also looking to do one on Next.js with Apollo client. So that will be exciting. We'll have some kind of an SSR application and some sort of a Jamstack workflow as well. So we'll have two kinds of modes that we'll configure and see how we can leverage GraphQL on that. Right. So that's it for today from my side. Thanks for joining in. Hope the tutorial was easy to understand, and I'll catch up with you folks next week. Until then, it's bye from Praveen. See you folks.